Yeah, so HuggingFace, if you haven't seen it or used it, what I tell people is it's GitHub for data scientists, right? So GitHub, if you've used it or know about it, it was the way that like the open source community really was able to come together and share code on a large scale with like total strangers and really work on these complex projects together. HuggingFace does the same thing where it really facilitates collaboration on these machine learning models and algorithms and data sets and all of that. So that's kind of my, like, in a nutshell, what I've understood HuggingFace to be. And we will jump into each one of those things in a little bit. So first thing, you'll notice I did not create a PowerPoint. I was debating on whether or not I was going to make a PowerPoint for this, and I decided, you know what, since we're going to be like in the code most of the time, I've also been really interested in getting more familiar with like how to use Jupyter and scientific notebooks, Python notebooks, and get more comfortable with those. My kind of Python almost, like, I've never touched one of these professionally. Nobody I know does, so it's like very much like outside of my realm. So I was like, you know what, I'm doing all this in Jupyter because that'll be fun. So let's jump up here. So Jupyter Notebook, if you use VS Code or whatever, you can definitely get this set up. There's also cloud options, if you want to run it in the cloud. And also Google Colab is a great option as well. Lets you run all this with your, it'll have its own GPU, CPU, and all that kind of stuff that you can make use of and run it in the cloud, which can be very useful if you're wanting to do machine learning on a tiny little Chromebook or something. So yeah, when you're in these notebooks, they give you access to running basic shell commands and magic commands, things like that, as well as running Python, as well as writing Markdown. So this is all just Markdown here, and then this is just a little code block.
Are you in VS Code?
Yes, this is VS Code.
Okay, cool.
Yeah. So yeah, again, like I use VS Code all the time, but for a totally different use case. So I was kind of excited to be able to do this. So the HuggingFace packages that we're going to be looking at today: Transformers, Diffusers, and data sets. I don't know if I spelled that right. And then also I'm going to be using PyTorch. If you are somebody who's like, oh man, but I use TensorFlow, or I use, I think Keras is another one. There's a handful of these main machine learning libraries that work with HuggingFace transformers. And I was saying, I know Keras is one. I wasn't sure if that was one of the ones that they advertise that works with HuggingFace or not. So I'm using PyTorch for that. So that's my environment. So let's jump into transformers, and going to be starting off with an example pipeline for a summarization transformer. So the pipeline convenience function, if you go and look at HuggingFace transformers, almost every single example you'll see will start off with like a pipeline function. This you can think of as a factory function where you call it and it will create a model class instance for any host of machine learning models. And so here, if we're looking at this, you can see you can tell it the task you want it to do, you can give it the model ID, and all sorts of configuration options. So I said I want to do a summarization task. And that said, okay, you didn't tell me which model you want, so we're going to default to this one. And it's going to be using that for the model as well as the tokenizer. So if we jump into here, we can see that it decided that this was probably the model I wanted. And you can read more about how this model works. You can see how it was set up and how it was trained. It's very similar to like GitHub. It's got all sorts of community aspects to this.
Is this a language model?
Yeah, so this would be a language model. It is based off of BART, if that means anything to you.
Okay.
Doesn't mean anything to me. But actually, that's something we'll talk about in a minute. So, at any point, if you want to stop and ask me questions, please do. And if I don't know the answer, which is probably the case, and somebody else does know the answer, wants to bump in, just let me know.
And so on the right-hand side, that's a sample of like
Yeah.
input and output from this particular model.
Exactly. Yeah. And you can see it'll tell you like the data sets that were used to train it. It shows like who's using this model. I thought that it also showed you if there were models that were fine-tuned from this model. I'm not seeing that right now, but I do think that there are links to that.
In your code example, you had this string summarization. Does this pipeline, is that just a label that you selected, or is that something of significance that?
Significance.
Okay.
Yeah. And so,
Like a constant.
yes.
All right.
Yeah,
Understood.
we can go in a minute. I'm going to just go through and do like a big old like rapid fire run through a handful of the different pipelines that they have.
Cool.
And so yeah, we can looking at the model that it gave us. It's BART for conditional generation. And so I went up and looked what that was, and I put that into this big text string here. And then I said, okay, summarize it, just to see how this works. So the BART model was proposed in BART, denoising sequence, the sequence pre-training for natural language generation, translation, and comprehension, yada, yada. So if that means something to you, cool. So yeah, for me, I'm still kind of more interested in just like how this like high-level API works. So I wanted to do it a little bit broken down. So I'm importing the auto tokenizer and then also that model that it was using for, or the class rather, that it was using for that model. Very similar. I am saying instantiate this model from a pre-trained model. So I think I'm using the same word, overloaded, but if that makes sense. And then here, instantiate the tokenizer from, again, from that pre-trained tokenizer. And backing up a little bit, talking about what is like a tokenizer, what is this auto tokenizer? So nearly every natural language processing task begins with a tokenizer. A tokenizer converts your input into a format that can be processed by the model, right? So every model needs a very clear set of like how the data is going to look. You can't just say like take a JPEG image. It needs to first translate that into like, okay, this is what this model knows how to read, and then spit it back out to a JPEG or whatever you're trying to do. So if we look at this here, this is the big string from before about the summarization, about how about what a BART model was. And I said, again up here, create the inputs based on that string in the PT, which is a PyTorch tensor. So it gave me this PyTorch tensor. So this is something that the machine learning algorithm is able to interpret. And then the model, so let me back up here. The model that we got from this, I'm saying now generate from those tokenized inputs. Gave me this output. And then I'm saying, okay, now decode that back into regular strings that I can read.
So from what you've seen, does the tokenizer always return tensors, or are there other return types depending on the model? I mean, I would imagine it would work on tensors. It seems like models want to work on matrix math, and so.
Yeah, I think it's almost always going to be like you said, matrix of some sort.
Okay.
I don't know.
My tensor sort of is a matrix, but it's
Yeah.
like a specially coded matrix that then applies those algorithms to.
Matrix is a type of tensor, if you want to get real mathy about it, right? It's the second one. I forget, whatever, yeah. Yeah, right.
Like a lot of natural language models, when it encodes it basically like finds all the words, and each one is assigned a number. And so
Okay.
it doesn't really deal with words because it's all math behind the scenes.
Cool.
Cool. So let's jump back to our overview here. So that was just looking through like the pipeline thing. So now I want to just kind of do a, like I said, rapid fire. Let's run through some examples of different pipelines that the HuggingFace Transformers API makes super straightforward and simple to use. And we'll start with the natural language processing ones. So conversational, right? So input of string, output string. Again, pipeline factory, I'm giving it this task ID, task type ID of conversational. Create two conversation classes. And here you can see that this is the output that it's giving us.
Excellent.
Which was?
Question answering.
No, just saw the big Belsky.
Yeah. Yeah, I approve. Question answering. So, and this one is kind of interesting because a lot of these, you give it context as well as a question. So here I'm saying, like, give me a question answering pipeline. And again, you can see it just is picking a model for me. And it does say don't do that in production. I was showing my my partner this, and she was like, "Well, duh! Like you just told it the answer." And I do think, like, you know, when we're in ChatGPT land where it's gotten so advanced, we like I think we look at some of these and we're like, this almost seems too stupid. So part of what I would say to that is that's like the default, probably very tiny model that it's choosing for my task. If I wanted to, I can jump on here and browse by these question answering models. And there's all sorts of different models that are fine-tuned on different languages, on different data sets, etc. And I can tell it to use that model instead. And you know, they're all different sizes, etc. And then also a lot of these are, you know, you'd expect them to be faster or more performant, so that way you could use them in a certain setting without requiring like giant GPUs running and all that kind of stuff. So that one I felt like I had to say that. Text classification, you know, give it a label, positive, neutral, negative. So here, sentiment analysis, it's given you this kind of an output. Just some more examples. Grammatical error classification. So yeah, Oh wait, did this one not, I didn't run this one? Yeah, so this one's saying it's got errors. And you were mentioning Grammarly.
Yeah.
I was looking, Grammarly actually does they're fairly, they are fairly active on here. I was going to say somewhere around here you can see like which companies are contributing, and Grammarly has a lot of models that they've been posting up here for their things. Text generation. This is like you know, when you're typing an email and it's trying to guess what you're about to type. So you give it some text. So.
Do you know when it's maybe a dumb question, but that's what we're here for, right?
Yeah.
When these models are being utilized, not when you're creating them, are they using the GPU during utilization, or is it just the creation time thing? Because I know there's like a lot of training that goes on, very GPU intensive, but I don't know if like on the flip side, do I also need a GPU to?
It does really depend on the model, yes. Some of the models, you know, like some of the models are taking days or longer to just train, but then they also require like a very performant computer just to then run the question through. Other ones.
That's dependent on the number of parameters you feed in and how big the data is, and then like you can set how many times. Basically, what it does is it takes a guess at all that it could be a million parameters. If you have a million parameters, it's going to have to go through each one of those, right? And like, if it's like a neural net, it's not just once; it's going through each one of those and all these different combinations. So, and that's why the GPU and the tensor is basically a mathematical representation of that data, but it's in such a way that it can be operated on like as arrays.
Okay.
So it's still faster, but in most cases, it's the reason you do that GPU is it's not just going to go through that once. It does it over and over and over. And each time it does it, it goes back to each one of those little nodes and says, how far off was I? You know, like I expected A and I got B, how far off was I? You know, and then it'll go back through. It's called back propagation. Then it has to look at each one of those and say, well, where did it look like it was going off the rails? This was close, that one's not, right? And so then it'll tweak that parameter and it runs it back through again.
Does that imply that the result answer may not be deterministic? Like if you ask the same
Absolutely,
question.
and that, in fact, certain ones, like a lot of times it's looking, certain algorithms will be looking for a minimum, right? But that might be a local minimum. So it may get down, it's converge on this number, which may not be the best number. It may be the one over here. So a lot of times, that's one of the reasons why you'll notice it's when you first see it, it's strange, but you start with random numbers, right? You just guess what those parameters are. Because if you set them all to 1, it's always gonna, you know, it might sort of be deterministic, but it might not be right.
So in that sense, like, I guess what you're saying is if it's deterministic, it might like depend on like the random seeds that you are specifying?
Yeah, because you have to start with some value for each one of those parameters, and so normally it's random.
Yeah. And I just asked that because lots of these have been fairly deterministic. Like, you know, you run them 100 times, they give you the same answer. But
it's
They
not,
could just have a high confidence in the, like, if, you know, that question with the where do you live in the context of like there's only one
Well, you
real
can
obvious
also-
answer.
but you can also tune it. So I mean, there's something called the confusion matrix. So like there's true positives, true negatives, and then false positives, false negatives. And you can tune the algorithms, you know, to be highly focused on one of those if you want. Because like for a good example that's used a lot is if you're looking at images to say, is this cancer or not? Well, do you want to be more, you want more false positives and more false negatives, right? Whereas if you're like, well, should I send this person an email? Is it worthwhile? You're probably going to be on the opposite of the scale.
great questions.
I have a HuggingFace question, maybe this is the right time, because you were talking about, you get these models already pre-trained. Where's that training data and how does that training data live with a model? So like, for instance, you showed a window where we were seeing a HuggingFace model, we were selecting some code and some other stuff. Like, where's the actual, all those weights, right? We did all this work to sort of train this neural net, we got all this back propagation, we've got these weights and this sort of, all of the sort of parameters that have been kind of figured out over time. how's that data live, I guess? That's always the question I've always kind of wondered about this sort of thing.
So,
Maybe it's,
like, so,
oh, it's a dot, I guess that's it.
Okay, there you go.
Okay, so it's just like a bin file.
Yeah,
Python knows how to
yeah.
read it. So PyTorch maybe has some like format that it can load, like, okay, that's kind of cool. I should never do this. I just always-
it's so actually, that's something I did want to, let's go back here.
Is that the training, like, is that the question I have kind of online with that is like, is that the output after the training? Like,
This is, yeah.
That's the-
versus the corpus that's used to actually train.
Right, that's
like
the
that
weights
might
from the
be,
neural net inside that bin file, I think, all the weights.
Right,
And so
right.
Yeah.
Normally, if the model's trained, you don't need your training data.
And in fact,
And it's usually not one, well, the other big thing is that it's usually not one training data set. You break it into some that you're gonna use for training and some you're gonna use for testing the output, like as you're training the model.
and I think that's what these big companies are fighting over, right? Is having the corpus to make the best AI by, you know, we have all this extra data, we're Google, so we can make the best model because we've slurped up the whole world in terms of information.
But they don't share the data, so we don't know whether they really are or not.
Right.
Yeah. There's a lot of, the big thing right now is there's a lot of bias that might be put into the model just based on the data, so.
Yeah.
and then also the I'm not sure if you just said this, but the data that was used to train the model is often secret, right? They don't want you to have it. So like Google and others are pushing up these public models, but they're not pushing up what made those models. So like in that way, they're like, hey, you have this awesome model. We're being so kind to you. But it's also like, it's not, yeah, they're not giving that much to the community by doing that.
So basically sharing that bin file, all the weights, and how they got the weights is like, well,
Magic.
we did some stuff.
Um,
Really hard, you don't have to now.
But in most cases, what it's training is actually values for all those parameters that you give it.
And I was trying to find, because I know I was like able to do this previously, but what with the HuggingFace libraries and a lot of these other like high-level like wrapper libraries, what they're doing when you say like, give me a sentiment analysis pipeline. In fact, I can show this happen because I didn't actually run any of these. So if I take off this model and we'll tell it to use the base model, it is going to download oh, you know, I already did this. But it's going to download the model when you first run it. And that might be like the one we were just looking at, 9 gig model, and it downloads it into like my cache directory here, and then every time after that I run that, it's going to use that model. But then if I tell it to use a different revision of the model, it'll re-download it, et cetera, et cetera. So so that's why like some of these things seem like they're super fast, and it's like I didn't actually show that it's downloading these models every time I'm asking for a new pipeline.
Well, all those libraries, there's multiple parts. There's one part that helps you train it, but once it's trained and you have those parameters, you don't need that data. You just basically feed it a new set of data, and it's not trying to train at that point. It's just using basically the algorithm you came up with in training. So that's usually really fast. Because it's really only looking at one small bit of data, and it knows how to mathematically process that fairly quickly to get you the answer. But where the training is just can be millions of iterations of guessing and adjusting.
So I want to jump forward, and then we can jump back depending on how people are feeling. But there is something that I wanted to jump to because I thought this was very interesting, and I did not know about it until I was preparing this. So this is very similar to if you're a GitHub user and you know like GH Pages. This is Hugging Face's version of GH Pages. So here I have, this is like my GitHub user. This is like a public, public URL. Where did that go? Not that one. It did just disappear. Oh man. That's silly. Well, let's open that again. So public URL, and it is capable of running a full, one of these models, and so in this case, it's the summary model that we were starting off with. So and it is so this is hosted as a Git repository. So right over here, you can see I've got my 4 files here. I'm giving it the requirements.txt, and it installs all of that. I'm using Streamlit. If you've used Streamlit in the past, it's a great way to just really quickly make a user interface. And so in this case, I've got my pipeline. That was like how we started this all. And then I'm saying Streamlit add a title, Streamlit add a text area, enter your text here. I'm giving it a default thing. Add a header with a divider, and then if there's text, so this it's kind of magic, where it's going to, like, if this text area is spitting back text, I'm passing it through my pipeline, and then I'm putting it in a markdown output. So then if we jump back to that,
so Hugging Face is running your code?
It is running my code. Yep.
Oh, that's bold.
Yeah, and I mean, it's not only running my code, it's installing requirements and.
Yeah, how do they sandbox all? Okay.
Yeah, no,
I don't want to be their security guys. So
Like
it's
something.
and yeah, just if you're like, I'm like, you can. I started doing it just here in the editor, adding a file and everything, but then I was using it here locally for. Just because I got my Git set up and all that stuff, so it's just like a normal Git repo. But yeah, you can specify your all of this stuff. So if I say, like, yeah, give me I don't know, 142 gigabytes of RAM, why not? It's ridiculous. And terabyte of storage. I have no idea how they're able to keep this so cheap. That's, like, honestly the big question for all of this stuff is how on earth does Hugging Face afford any of this?
Are they a company or an open source thing, or?
I did not prepare that.
Okay.
I don't know.
You can use it for free, or does it you have to pay?
No, everything that I've shown you, this is all free. So yeah, I'm on the free 2 virtual CPUs and 16 gigabytes of RAM.
Can you tell me more about the Streamlit? I feel so, like, behind. This is something really cool. You're like, oh, Streamlit, whatever. Like,
Yeah.
I've never heard of this.
Yeah. So no, it's definitely something that's, I feel like, is in, like, data science space. So it's not something I have used, like, on the job or anything. So I really recently found out about it and was, like, kind of amazed.
You can tell it's data science because they immediately use the as keyword.
As, right? You just can't use tangents about
Can't.
something, right? You have to-
Heaven forbid you actually use the word Streamlit
Right.
in your code.
Yeah.
Two other commands, right?
And yeah, so running it on my local. So I think I just did pip install Streamlit, and then you say streamlit run app.py, if I'm getting this right, and it just opens up like a local host.
Oh, that's cool.
Yeah, so that's really cool.
So like, if you, I guess if you wanted to have your own, you could like create your own Streamlit server and like, let's say you had a team, you're like, okay, everyone, you're all gonna be able to do Streamlit stuff. You could have a server that runs Streamlit apps and people put their apps in there or something, I guess. Is that what it's like a framework inside of the,
Lo-fi, you don't have to do the web stuff if you don't want to, but yeah.
Yeah. It does seem to support like a good amount of, and it also has things like a whole plugin library. So,
How this compares, because there's that other the guy that's doing TUI interfaces, textual.
yeah, yeah.
Seems similar, slightly different.
So I did want to just show how easy this was to set up, because this was a very last minute addition to this talk like 4 hours ago. So it again, if you're in the GitHub world, I keep saying that because I'm in GitHub all day long. So it should feel very similar, repo name, pick a license. These are some of the other Gradio I have not used, but I assume it's similar to Streamlit. And then it also lets you like host Docker as well. So
That's crazy.
yeah, so there's a lot of stuff going on here. That's the spaces. And then just real quick, want to jump in to talk about the data sets, because this is something that I think is also very useful. So again, it's a HuggingFace library, just pip install data sets. It feels and behaves very similar to the Transformers ones we were just looking at, where you basically load data set, and it will look on its public repositories for those with that ID. So there's one with an ID of Rotten Tomatoes. And it.
Can you please repeat that? The Rotten Tomatoes?
Yeah. Yeah. So it'll give you like a summary for explaining like where it came from.
So these all are publicly available?
All of these are publicly available. I think it's possible to have private ones within your org, because like it did ask, like it's been trying to tell me, like it's been really trying to push me to create an organization. So I assume that that's how they make their money.
That's where the income is. The business
Yeah.
model.
Yeah, this is a big sales pitch for HuggingFace. But yeah, so it's a really great way to share data sets, because like if you read anything about like ChatGPT and all this stuff, everybody's like always says like it's about quantity, yes, but it's really about quality with the data sets. Like it has to be hyper prepared. You really have to like clean your data set in order to get any useful stuff from it. So I feel like this definitely helps with that. So here you can see the data set. It gives you like the training data set, the validation data set, and the test data set. So you can use them for those three different pipelines, or different word for pipeline, sorry, those three processes. And here's just a little idea of what it looks like for the Rotten Tomatoes reviews. It also supports things like image data sets. So I found a Pokemon one. So you can see like it's just like downloading stuff into my local cache. But there's some audio ones. I got real stuck trying to get these audio ones to work. So I never actually got this working where I could use it, unfortunately. But what was
AI generated audio?
It's not AI generated audio. These are just data sets of like
okay.
for training your for
I see.
like if you want to train a speech recognition thing, for example, it'll have like here are like 10,000 audio blips
Yeah.
mapped with 10,000 sentences of what they are, and they've all been prepared with the right like they all have the same like bit frequency and whatever, so you can easily
Nice.
like that's kind of the idea anyway.
Good public sanitized data that's been annotated, probably.
Yeah.
Actually, like this is a dog, sound of a bark, or a,
Yeah.
cool.
Yeah. Where did that? So you can see like yeah. I mean, there's all sorts of stuff here. Textbooks. So it gives you like outlines and fields and stuff. But it's all public, like these names of people are like obviously not like reputable or whatever, so you have to do your research before you pull any of this stuff.
Cool.
I saw
And
one the other one said like Cornell.edu. You look up like Cornell as org and see like their verified models.
You can cultivate like a good list of like, okay, yeah, we need to learn from this, right?
I mean, maybe.
Cornell.
So the answer is yes, because I know Facebook has they have their org, so they have their company here, and like here are their models. So you've probably, if you've been interested in like the ChatGPT race, that Llama's very big in supporting like the open alternatives to that. And then stability AI. If you are into the open alternative to DALL-E for image generation, Stability has been really pushing a lot of that. They've also been pushing all sorts of stuff. So yeah, so you can kind of like get the idea that these are probably worthwhile. And I just real quick, I can show you. I did have an example for stable diffusion. So yeah, I don't have to go into all this, but diffusers it's like a different architecture. So they, for some reason, it's not under the transformers, even though like the API seems very similar. It's in a different library, so installing a different library.
Is it also from HuggingFace, or is it?
Yes,
another project?
yes.
Okay.
So it's also, you'll see it's like the exact same thing where I'm giving it a model ID. This was interesting. I was going to bring this up with your question for GPU. A lot of these will show examples of sending it to CUDA, which don't ask me what that means, but in this case, I'm basically able to say, take this model and move it over to my M1 chip, and so it can run a lot faster. I'm sure I said that wrong. And so yeah. See, just a little blip there. And then I know that a lot of you, especially if you do know more about machine learning, you're definitely more interested in like the fine tuning and training aspect. They have all sorts of tutorials for how to take your trained models, push them up, take down other people's models, add a layer on top of them, push them back up, kind of thing. So I'm not going to pretend to know how any of that works, but they do have pretty straightforward, helpful tutorials for that. And I think that's it for here. Guess open it up to questions or anything people want to just have me pull up and we can look through together.
I really like that you showed how you integrated all of these pieces, because I use BART a lot and I see the output because it's live. It's not like ChatGPT 3.4 that is offline. So BART is live, and so I said, write me a Python program that will find out ICAR malware. Start thinking, and it gives me a bunch of code. A lot of things, like you said, it needs to be trained. So you were mentioning, so it's just going to remember all that. And I said, well, it's not exactly what I want. You give me too much. I said, I just want to find out how I can take that string and break it down so when the, I don't know, McAfee is going through it, it's not going to erase it. So I'm verbally telling it, you're doing everything, but you found a way to integrate this, write the code, and do everything that the verbal version will do in part. So you know what you're looking for, but more specifically. So it gives you all these different things. I see the icons. I paste it like a picture of a dog, and I say, tell me what kind of a breed is this dog? And then you start looking at it, and it comes back with 16 different kinds of breeds, because it's just looking at all the different pixelations, and it's like something like, maybe it's a border collie, but it has some traces of some other breed, and you're like, it cannot be possible. It's not what I'm looking for. But then you keep telling me, and now I want you to do X, Y, and Z. And then you see the output of that, of training the model, so it will keep refining it. But I never knew, till now, how you compose all this. So, for example, Chris said it was Chris, right?
Ricky?
You're Ricky. You're Chris.
Yes.
Okay. So that would be a really good place to start playing on how to, get familiarized with, the sandbox of all these different elements.
Yeah, it's something interesting that is making me think of, and something that I feel like this part of the like this level of AI, where it's very sort of high level of just picking and choosing these models. If you watch, like, I personally, for some reason, decided to use Bing as my main one. I don't use ChatGPT directly, but you'll see that it's really like an amalgamation of multiple models working together, right? Like, you ask it a question or something, it's going to then perform various like searches to its search engine, right? So it might be like a slight variation of their main GPT-4 model or whatever they're using to do this, but they basically have to first take your question, break it down into what more information do I need? All right, do those searches. All right, now let's take those results and say, like, what do I need to feed back into this thing? And then now that I did this, like, what am I going to like layer on top with, like different annotations, etc. So like there's a lot of like, it's not just a single model oftentimes that's doing the whole thing. It's really many models working together to make the process like end to end for the user.
It's like a model that references other models.
That was actually one of the questions I was gonna ask, is like, we have the pipeline here that you were showing us. And all the examples, it seemed like you used one model, you put in, embedded some stuff. Do they provide, like, the name would imply to me that you could like chain things perhaps, like you have the scenario where one model is, just to think of a silly example, like you have a full story and you want to summarize it and then pipe it to diffusers to create an image out of the story. I don't know if there's any, if you've done any work where you actually did chain together multiple pipelines in interesting ways. If you could comment on that, or if you've seen anything like that, that'd be cool to know about.
I was gonna say that sounds a lot like what I'm not too familiar with this. I want to just see like a example.
Like if you look on Kaggle, like any of the winning ones, it's almost never one model or one algorithm. It's usually combinations of them.
Okay.
But the pipeline, a lot of it is really, it's not just what it does after it. Part of the whole pipeline is like you take your data, you gotta clean it, you may have to tokenize it, digitize it. There's all kinds of cleanup and other things. You know, like if you're doing natural language processing, they have to do some stemming so that it, you know, like words are treated somewhat the same.
It's
So
never like pluggable, like just pipe.
But the big thing is a lot of this, it's like, when it's, do you have that slide where you we first created?
The very first one, yeah, what was that, this one?
This one where you dump out the model. It shows you all the little pieces.
Yeah, it's like a list of all the little cleanup things and feed it into the neural network and then turn it into.
This guy right here?
Yeah, I think it was right at the top where you, right there, I think. When
Here?
you do the summarizer. Yeah, when you do the pipeline, it's not creating just one thing. It's got all of these little pieces that if you add them in, it may do other functions.
Because that'd be a pretty interesting world where you could just, like, I'm thinking in my head like a command line Unix pipe where you're like, one command, another command, you chain them together and
So,
do things in interesting
I was
ways
gonna
that way.
say LangChain is one library I know that sets out to try that. I've not actually used it, so I can't say for certain. But it's the idea is that, like, you know, chaining.
Oh, they literally have their chain one, they use this pipe characters, interesting. Okay.
Yeah, so it's
But yeah, even a simple one, it's got to take the data,
Yeah.
tokenize it, train on it, and then part of the pipeline may also be, the next step will be, then you take that, one of those holdout sets, and you do, you check then you take the model you train, run that holdout set through and say, how far off is it, right? And then once that's done, then there might be then once that's done, there's be a piece in the pipeline that will take the data and detokenize it to put it back into something that's readable.
Okay.
So, but all of those pieces are, so the pipeline can be, you know, three parts, or it can be 100 parts, depending on how complex.
And I heard you mention Kaggle, and I figured that that's probably something worth just throwing out while we're talking about this. It's got a lot of overlap, I think, with HuggingData. Do you use it frequently? Would you be able to give an overview of what it is?
Kaggle is more, I think, I'd use it more to learn how to do stuff and look at things that other people have done. But they also have a fair amount of data out there that you can use for your own purposes.
It seems like it's a mix between HuggingFace and then something like Leet Code, if you know, if you're like that kind of programmer. Where it's like, yeah, there's a lot of like, yeah, there's a lot of competitions, I know.
It's like, it is itself a benchmark for developers. If I've seen a lot of my friends, they are like competitions, they go to code, and if they win, that also satisfy the level of expertise that you have. And mostly data science, and there are a lot of free data sets in there. So they've been constantly redeploying and about the cutting edge new trends and technologies that come in. So mostly that's what I wish I could own one.
So if you're an aspiring data scientist, it sounds like a good place to go.
Yes.
maybe.
I mean, if you have basic understanding, and then you can start exploring this, or gradually, like, you know, go for at least a year, try to win some competition. Meanwhile, through the process, you'll be a great asset at some point.
The like
Yeah, you
the.
can compete, or you can look at the results from other competitions and see
Yeah.
how they did it.
I was gonna say the most famous one I feel like what is the
Yes.
Titanic prediction, that competition of like who's going to survive the Titanic.
You know, the funny thing is that there are a lot of cable celebrities out there. This is one.
So David, I have an idea of the thing you should do. You should totally take the, I'm gonna take.
I should do.
Yeah, you should, you're talking about this, you're responsible. Now, so you're talking about pipelines and feeding these models in together. I imagine you could come up with this telephone game with the model, right, where you give it some text, make a picture. Hey, summarize that picture. Hey, make a picture from that text.
See how
You
long
feed
it takes to evolve.
And see how bad it gets. It's
Yeah.
a fun ride, I think.
I actually was if I had seen the Streamlit thing earlier, and like I said, this was very much a last minute addition. I was planning on doing that, whereas like it would like do a exactly what you said, like random text for like make a weird idea for an image, and then a weird idea for an image, and then what is that image? And then make an image of that.
I think I'd give it like 3 pipes before it devolves into racism.
Or it could be already an idea in play for the R&D. You know, you hear the voice translated to text,
Oh, yeah.
and then you
Real
have
telephone, yeah.
you have both parameters forming into a face. You know the region of the person is calling from.
So many possibilities.
So many possibilities.
And
So there was one other random little thing. I saw a sneak peek on one of your notebooks where you said it would generate random Garfield cartoons. And I want to do Garfield cartoons.
that's funny. So man, did I not? I think it wasn't as good as I was hoping. But yeah, you can see it trying. It's trying. It really is trying. Oh, there was a few more that I skipped because we were running through these. But now that I'm here, they were really exciting. Depth estimation. So you give it an input image and it'll give you that. So you could see that.
That's so cool.
And then image classification, image to image, object detection.
I see lots of like Photoshop tools, like their back end functionality in all these.
Yep.
And then there's like a whole category of multimodal, which is basically, both and kind of thing. So like you give the model text as well as image or sound or something. So this one, I was like, what is this astronaut riding? This is, again, telephone, because this was something I generated, right? And it was like, horse, pony, yes, was my favorite answer.
What is it right?
But this, I wanted to show this because I thought this was kind of clever. So we all have seen these, right? And so I literally just broke this up manually into 16 bits, but you could probably do that without doing that. And then I said, for each one of those, ask, does it contain a traffic light? And so it was pretty good. It was it said these 3, and then it said, I think this one. So you can see some good practical applications. So, yeah. And on the top of CAPTCHA breaking, so HuggingFace had a really interesting CAPTCHA, however you say it, where I had to tell it, it was like given it was a map and like a few lines, and it was given that the car starts here, select on the map where the car will end. It's like, they're training it on pathfinding now, that's cool. So, anyways.
So can I ask a quick question about it's a little off topic about the CAPTCHA. So why it shows that, or why do you have to go through this? Like my question is a basic understanding about this. Because I've seen like many times you log in, authentication purpose of the ask is, and after there is a, what, you are not a machine or something, right? So my intention is to know what's the back end thing, how it's exactly it authenticates. Any idea what? Am I asking the right questions?
Unless you work for Google, you likely don't know, because Google isn't telling. This is their reCAPTCHA version 3, and it's doing more than just seeing if you can pick out those components. It's also looking at your browser history and analyzing that to say, is this something that a human would do? Would a human go to these websites or have these cookies? So it's doing some other things. And that's why
I was just about to
it
say
does
that.
as well.
Oh, yeah.
The exact algorithm, they have some shady stuff.
Yeah. Yeah, no, that's why like half the time it's just like, are you a human? And all you have to do is click a button, say yes. Because it's like, oh, I know, don't worry. It's like, I know you. We tight. Yeah.
We're just distracting you while we look at all the other stuff on your laptop.
Yeah, sometimes I get that, yeah.
But the other thing is, and I know a lot of you already know this obviously, but anytime you're asked to do these kind of menial things, you know that they are collecting very useful data from you that they can use to then train their, they want to train their self-driving cars. The whole, this all started with Google Books, if I remember my history right, where Google Books had all of this text data, and they wanted, it was like, you know, literal scans of books, and they wanted to just turn it into digital books. And so they wanted to train their machine learning algorithm to be able to read the images and turn it into text. So they started using CAPTCHA to say like, translate like this image of a book and like write out what the sentence is. And so then they got like loads and loads of data on that.
And you trained those, and you probably saw 2 of them at the same time. So you had to answer one, and that was probably the known set, and then you had to answer another one that's unknown. So basically testing you on one and training the model on the other one.
To know if we can believe your confidence.
Yeah.
So what if you go by your definitions, as you said, because I haven't. So for the fresh browser, for the first time, on a computer, any device that I start to use, and try to be more precise without pinpointing my what I have to say, no mouse movement. I mean, I'll try to be pinpointing that, so it might have a better chance for the machines to learn about my behavior, like in the browsing behavior. Because if it tracks even your, like, how can I say, the mouse while you are, the cursor while you are hitting the, because as a human, we try to see and then we move frequently. Right? Well, the machine would not like to do that.
Yeah.
Still simulate all that stuff, right?
I mean,
Sure.
I have a lot of it, right?
so that is why I was asking, why is there anybody else, any machine that they have created and try to, like, you know, read the caption? So far, if any company or anything that have created that to.
Yeah, I mean, I think that's like a whole market, and it's a an arms race, right? So they make their CAPTCHA more difficult, and then, you know, the thing that's breaking that, it gets better at like solving that problem. Like that's why this, for example, like you can tell, like I'm well on my way where a public model is able to give me pretty good answers for that. So like this is not.
This is over. I think CAPTCHA is lost, just from what I've read. It's like most
Really?
are getting defeated these
Wow.
days. So yeah,
Well, there you go.
that's the world we live in. Do we have any other questions on this topic for David before we wrap it?
Yeah, sorry, running a little long.
Not so much a question, but it seems like, and especially based on what you were saying earlier, it all sounds like all this really is just specialized evolutionary algorithms. Because you were talking,
It's all
stuff
math and
where it's almost like it's
statistics.
fitness functions, the heuristics
Yeah.
to define.
Well, that's basically what most of those algorithms are doing, they're fitting some kind of curve, basically. So, I mean, a lot of them, like the regression models, you think you have some like really complex polynomial equation where each one of those coefficients is one of those parameters that's going in, right? And so, it's just trying to, as best it can to fit that curve. That's one of the reasons why it's not always gonna give you the same answer. It depends on what you guess is those starting values. Occasionally it'll get down to like a dip, and it keeps going lower and lower in that dip, and it can't get out of it, but it may not be so I mean, there's all kinds of ways to get around it. So like, one thing is you can do is you can train on different data sets, and then compare them, and then sometimes you have enough data, you can do enough trainings that you then average out those parameters. So.
Well, I was just thinking, because it was, for my master's degree, my final project was actually, I don't know why my professor decided to do it, but my team wrote a genetic algorithm to solve algebra problems. And it was all just randomly generate data, run it against a fitness function, mutate it, and just kept running until it hit a certain percentage of,
It's pretty cool.
to find the maximum basically. So it kind of sounds like what most of this is.
Man, I'm not finding it. There was something that was really,
Do you remember the accuracy of the model?
one of these,
Stupid, really simple equations, so it was getting like.
Well, thank you, David. I want to. That was very fascinating.
yeah, and I was, I was telling